Are you tired of all your music gear falling all over the frickin' place? Do you wish you could plug exactly 3 pocket operators into a slightly larger pocket operator? Then you need the Pocket Dock. Yes, the Pocket Dock.
You heard right, the Pocket Dock, the only custom PCB that lets you interface any original pocket operator with Eurorack or Pocket Rack signals. This incredible new board uses the same footprint as Palm 400 modules. Just set your pocket operator into the dock, and you're ready to jam.
Using our patented springy thingy technology, the dock connects using pogo pins, transferring audio, power, and control to and from the pocket operator.
Once you dock your pocket operator, the power is in your hands. The first input is a combined audio and sync input. Audio on the right, sync on the left. If you have modules that get that wrong, there's a switch to reverse that on the back of the module. The second input is sync only on both channels. So if you have like a standard Eurorack LFO or something like that, you can still put sync in without having to split that out separately. All of the input stages go through a voltage protection. It safely scales from plus minus 12 volts down to 0 to 3 volts using the input stage from the EuroPi by Allen Synthesis, which itself uses the ever incredible mutable instruments, the input stage from that. After that, the inputs are routed directly to the pocket operator via the pogo pins, and it does all its normal stuff from there. It doesn't even know that the input is different than what it would normally get by plugging a jack directly into it. From there, the audio goes from the pocket operator to the output stage over here. The top one, just like before, is combined audio and sync. And there's a second buffered copy of that exact same signal in case you want to easily split that out. The lower 2 outputs are sync only. Again, they're both buffered. These 4 jacks down here allow you to control knobs A and B on the pocket operator using control voltage from Eurorack, again, safely scaled down to 0 to 3 volts. If you want to daisy chain a couple pocket operators together, you can still do so. You could do the normal thing where you plug the output of one to the input of the other. Or on the back, each module has 2 JST headers, one for in and one for out. You can plug a short little cable from one dock to the other, and it automatically daisy chains any operators that you dock from there. And how does it all work? That's the secret. It doesn't. These are just laser cut acrylic boards instead of real PCBs. I've designed everything in KiCad. I've ordered the boards, but they're still in shipping. Also, I cannot find my pocket operator anywhere. That's why I made these cute little 3D printed models. If you do PCB design, I strongly recommend modeling your board first. Laser cutting, if you have it, is excellent, because then not only can you make sure it feels correct, that the sizes are all good, but also just to test all the fit, make sure I've got all the right parts for all the right footprints here. I've tested a lot of these on breadboards, and a lot of it works, but I'm still working on it. I do plan on making all of these designs freely available once I get the real boards and assemble them and test them out a lot, make sure they all work. But that's not all. If you call now, you can create an entire rack of custom new modules, all made to the Pocket Rack standard. As soon as I saw the DIY contest, I started designing the Pocket Dock from there, but I've been teaching myself PCB design for about a year now, and a lot of what I've been making is these synthesizer modules, so I've got a lot to share. All the modules I've made share the same power input stage. It's a great basis for all the boards. They all have either a 3-pin Molex SL power connector, which is what the regular Palm 400 uses, or a more standard 5x2 pin Eurorack power shroud. And that can be put either on the front or the back of every board. The back is the normal place, so you can plug stuff in when it's in a rack like this, but I'm also making a standard where you can put these little modules in a 3D printed clamshell case that closes over all the knobs and jacks, and you can set that down in front of your synthesizer, like flat on a desk. I'm calling that the Pocket flat format, but I'm still working on that. And here are the modules I've made. First, both chronologically and alphabetically, we have buffered mult. This is a multiplier, sort of like a power strip, but for audio signals. If you plug something into the first input, it will send a copy of it, a buffered copy, to the 3 outputs. And then there's another 3-to-1 below that. But the second input jack here is a switched jack. So if you don't leave anything plugged into it, whatever you plug in the first input will send a copy to all 6 of the outputs. Also, if you don't want a buffered mult, if you just want to not put any components on it at all, and you solder a few solder jumpers, then it becomes an unbuffered mult. So 2 modules in the same board, kind of. Next up is the clock skipper. I really like this one, although I do want to think of a better name for it. I wanted to make a very simple and very cheap gate sequencer. Gate sequencers tend to have their own internal clock source, and they make their own external clock, their own voltage spike. I wanted something that would use the existing stuff that I already have, though. So you plug in a constant signal of any kind, and it goes through a counter, an 8-step counter. It's got a little bank of switches right here, little teeny tiny ones. When the switch for that step is on, the signal passes through to the output unchanged. If you have a step with the switch turned off, it mutes it. 0 volts go through. It's super neat. This is one of the modules that I actually have working on a real PCB. I do like this one a lot. Next up, we have noise hits. This one is cool. This is based on Moritz Klein's noise Eurorack module. So it's got white noise, pink noise, and blue noise output, but I've added on each of those channels a swing type VCA. So when you put in an envelope, a spike of voltage into these jacks right here, they will control the volume of that noise. So if you send it from a sequencer like the clock skipper here, a little spike of voltage, it will make a short little hit of noise coming out. So again, it's for simple little drums. The thing about a swing type VCA, they do add a lot of distortion to a signal, but I figure if the signal I'm distorting is already white noise, it might actually make things better. Then I have 2 great modules here, the Nibble Core and the Pico Core, both by Infinite Digits. These are awesome. I didn't make these, obviously. I just took the existing design and adapted them to the Pocket Rack size. They're breakbeat generators, so they make super awesome, like chopped up broken beats. Love them. I don't have the Nibble Core working because I added a op-amp buffer on the output, and I think that broke everything, but I'll get that one working. Next up, we have something I really like, but I haven't done enough with, the Pocket Socket. That might be the best name I've ever invented for anything. I was making so many of these boards that had most of the same base parts. They would have input and output jacks up at the top, and they had knobs at the bottom usually. So I said, is there one board I could make that just has those, and then you click a second board onto it that does all the actual audio stuff? So that's exactly what this is. It's got these pins in the back where you can click on another board. I haven't made any of those daughter boards yet, but it's a good basis to do so. Also, there is a 3.3 volt and a 5 volt regulator on the back. So if you're gonna have like a microcontroller in the back, you got the power situation all sorted out already. It's cool. Last up, I have a dual quantizer. For now, I'm calling it Quant. Again, I want to think of a better name. I do like the module though. The heart of this is a microcontroller that I've just soldered on the back. Again, I use the same input scaling to make sure that it receives a safe level of voltage. This one has 2 inputs, so if you plug in any like random series of voltage going into it, it will round that and shape it into something that's more like musical notes on a piano rather than random sliding voltage. It's got these awesome little piano buttons right here. I've used this design in a few places here. On the back of this 3D printed case, there's like a shroud, and there's a separate 3D printed button that you put into that, and then the board with the real buttons on it that sandwiches it in place. So you get this awesome little click, but the buttons are locked in place. They can't move and they can't spin. This one has 2 inputs. If there's nothing plugged into the first input, it normalizes that to the second input. And the channels can be controlled independently. So if you have, say, the quantizer set to, I don't know, an F major scale on input A, it will output that into output A. And then you could set output and input B into, I don't know, an F major triad or something. So you can have two different instruments coming from the same quantizer. Or you will be able to once I actually finish writing the firmware for the microcontroller. And I made this power board that basically just matches the existing power board in the Palm 400, because why not? And that wraps up my entry into the Pocket Operator DIY contest. I had a blast making all this stuff. I hope you enjoyed watching the video as well. Happy music making.